Welcome to Euclidean. This is the first of the multi-part video on coordinate geometry. Today, I shall give a brief introduction to Cartesian coordinate plane and explain the distance formula. The subject of coordinate geometry is also named as analytic geometry. It is employed as an important mathematical tool in physics, engineering, space science, and many more versatile applications. It all started with the famous Greek mathematician Euclid of Alexandria. Euclid is famous for his 4th century BC text on mathematics named The Elements. The system of proofs contained in Euclid's Elements survive even today, that is 23 centuries later. The modern geometry is founded by two French mathematicians, Rene Descartes and Pierre de Fermat, in 17th century AD. Descartes is also generally accepted as the father of modern philosophy. He said, and I quote, "Je pense donc je suis," meaning, I think, therefore I am. This is a very profound philosophical statement that defines an individual. Euclid is attributed to definition of Euclidean plane in 2 dimensions and Euclidean space in 3 dimensions. Note the difference. In 2 dimensions, it is a plane, whereas in 3 dimensions, it's a space. On an Euclidean plane, the 3 angles of a triangle add up to 180 degrees, which we are all familiar with. For example, a flat tabletop. In a non-Euclidean space, the angles formed by a triangle do not add up to 180 degrees. For example, the surface of a sphere. The Cartesian coordinate system, which we are all familiar with, is named after Rene Descartes, and thus his name has been immortalized in the history of mathematics. I must add here that in 3 dimensions, the coordinate system is called a Cartesian space. So, let me list out some of the useful properties of Cartesian coordinate plane. It's a coordinate system in 2 dimensions. It is an Euclidean plane, a 2D plane usually denoted as xy plane. Axes x and y are mutually perpendicular. Very useful for plotting a graph of functions expressed as an equation. The x and y axis can be marked in any arbitrary units in real numbers. Next, I'm going to derive a neat formula for distance between 2 points in a Cartesian coordinate plane. First, I have marked a point A with coordinates x1 and y1. I have also drawn 2 perpendicular lines, one each to x-axis and y-axis, and marked them as D and E respectively. Next, I have marked another point B with coordinates x2 and y2 and drawn similar perpendicular lines to meet x and y axis at F and G respectively. Next, I will complete the triangle ABC. Note that the angle ACB is 90 degrees, that is a right angle, and ABC is a right angle triangle. The linear distance between A and B, which is the length of the line AB, can be easily derived using Pythagoras Theorem. It can be easily seen that the length AC is equal to x2 minus x1 and the length BC is equal to y2 minus y1. Since ABC is a right angle triangle with AB as hypotenuse, we can apply Pythagoras Theorem. Therefore, AB is equal to square root of AC square plus BC square. And the distance formula, which is the distance D between A and B, works out to D is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is an important tool employed frequently in solving many mathematical and physical challenges. So, this is it. Thanks for watching. Love to have you back again at Euclidean. Bye.